Hello, I am Parthy and my presentation will show how freeform architecture can be combined with instant freeform reinforcement. This first sheet will give an overview about my in-house developments. In chapter 3, I will speak about 3D steel fibers with slopes from 2006. In chapter 4, about Bionic-Mesh-Steel-Elements for 3D printed concrete from 2023. Number 5, 3D shapeable rebars with instant cages, a plug-in system from 2025. And I will speak also about pop-up steel fibers from 2024. Steel fibers that pop up in liquids. Chapter 7 will be about strength transforming when tensile forces are changed into compressive forces in the hardened concrete module. Number 8 is about similarity analysis and tensile testing on prototypes which are printed in resin printers, a study design. Number 9 is about FEM considerations to determine optimal loop shapes with slow computer craft. And number 10, the last, is about older patent literature that shows that older ideas keep coming back, but modified. The main thesis of my arming elements to reinforce concrete sounds: loops are cages and cages are loops. Because conventional cages in a reinforcement system serve to enclose the reinforcing iron, prevent buckling, act as spacers, redirect the acting forces. So loops perform the same function. Cages are loops and loops are cages. The small loops in inventive 3D fibers strengthen concrete just as conventional cages do it in traditional reinforced concrete constructions. I started in 2006 with that fiber element with 3 slopes in 120 degrees. Here you see 2 elements with overlapping, enveloping bodies. You can see these elements can be filled into a form and are homogeneously dispersed, and so they are very dense. This fiber idea is free scalable from 1 centimeter diameter up to 10 or 15. In comparison, these fibers are hooked end steel fibers from the same time. Different fuse onto 1 to 3 or 10 elements, which give a concentration which is very high of 330 kilograms per cubic meter. The manufacturing is very easy and can be made at the workshop. It will be delivered as coil of wire that will be banded and cutted. Some prototypes with very small diameter fibers, dense, and they can be filled with concrete slurry, keyword Zivcon. I will show you the video. In 2006, I did some testings in cooperation with company Arcelor and Mr. René Pepin. So we filled these bigger elements into the wooden form here from the size of 60 centimeters and 10 centimeters high. All in all, about 85 kilogram weight in total. The testings with a pressure tensile machine from Zwick and Roll, and we found a very interesting picture of cracks. Many cracks instead of only 4 cracks with normal steel fibers. And we can count 1, 2, 3, 4, 5, 6, 7, sometimes up to 10 cracks that collect energy. The results can be read here, but it's not the time enough to speak about all. The year 2023 came with a modified basic form from 2006 here, and this is the modified form which should receive higher overall strength and is optimized for 3D printed concrete. You can see these elements fall into each other and the loops penetrate into the other one. Looks in the top view, they are overlapping and intertwined. The perspective view show you they are tightly packed and the loops stick out to create a bond to the next layer. Here's one layer which is just hardened and the other one came on top. And these loops will help to connect both layers. The bionic steel elements can be laid down in different versions. First into the formwork by let them fall, and second versions are in layers by robotic arms. They put down the elements first on the track, or concrete first, or concrete and mesh mixed together in version 3. This remembers us for the Sifkin method with Bionic-Mesh-Steel-Elements and contour crafting. The manufacturing is the same as already shown for the older steel fibers. 3D shapeable rebars with instant cages are different. I show you how. The main element is a chain, a normal chain, and bolts and loop-shaped caging elements are inserted in the chain. After inserting, the chain is stiff as here shown, and can be formed by hammer onto the form. We have different kind of extensions with slopes or only rods with a thickening at the end. The bolt is put into the hole of the chain, but the chain is then not easy to bend. It's difficult to bend. There's a lot of friction around the axis because of connecting metal onto metal. In an illustration here you see the simple chain. It becomes shapeable reinforcing rod with extensions, and that can be adapted to a curve, whatever you want. Standard rebars for comparison, cages for comparison, and I say this rod with this extension loops is doing the same in a vertical column, for example. 1, or here 1, 2, 3, 4 in an angle of 90 degrees. We can use this for every application, any freeform building. The delivery form is from factory, elongated or coiled. So at the workshop it will be elongated and cutted. You can stock it on the lorry 1, 2, 3 above, and you can use it for sailings, load-bearing sailings. In this perspective view you can see there's a lot of space for concrete and there's a lot of metal used, the chains and the loops, and you can bring them in a curved form if you want. The pop-up steel fiber is an expanding fiber. It comes in 3 different versions, A, B, C, and is in a popped up version after it gets water, NX, or this form, or very elongated. The delivery form is elongated here and it expands to an X. But why? Because 2 glue points fixing the expanding X together, but the glue is water soluble. Version B looks before the glue comes as this. The glue fixes the pre-stressed lenses which occur after getting water, this tetrahedral shape. The simplest version is one slope pre-tensioned with an end hook, and it gets the full length of about 4 to 6 centimeters or longer after getting in contact with water. The length is increasing to get higher strengths. Yes, it looks futuristic to use variant A to unfold it in the concrete in layers by robotic arms and pumped concrete. It needs time to expand in the layers. In the first or second layer it's already expanded, but when you lay it, actually in the layer number 5, it's not expanded because the glue needs time to solve in border. Same with the different version in picture 6.13. Here we see how loops can redirect tensile forces so that primarily compressive forces act in the concrete. You see here the tensile forces and they are redirected onto compressive forces. in a system of concrete and loops. The white arrow shows the compressive force. Chapter 8 will discuss similarity analysis and tensile testing on 3D printed 1 to 10 models, a proposal for study design. We see the standard sample plate is very big and has a weight of about 85 or 90 kilograms. I will reduce all that and scale it down to 3D printing sizes. This will result in 1 kilogram or 60 kilogram, 160 grams, and size overall 20 centimeters. For freeform objects, these test specimens need to be developed and standardized. What we don't want to use is no concrete and no steel reinforcement. Instead, we want using plaster or 2K acrylic resins and 3D printed reinforcement elements. When we have that printed elements, I show you here, we fill it in a form of only 20 centimeters, fill it together with gypsum or transparent 2K plastics, and receive in a very short time, instead of 20 days of hardening concrete plates, a model that can be tested in very cheap desktop tensile testers, actually about 1,000 euros or less. This is the build room of a 3D printer or the slicing program, and you see in blue the resin printed arming elements, these loops, and the red one here are supporting structures that are very thin and will not influence the main characteristics of the embedded model. Finite-Elemente analysis will help us testing without concrete and steel at this stage, and it will save time with the radically abstracted loops. Following next page. Here on the left you see the Bionic form, and on the right the radically abstracted angular element. Parallel nested loops were booled together and a concrete block is added here. A short view onto older patents. Without comments. Thank you for your kind attention.